Hello, and welcome to today's lesson, Algebra Skills and Geometry Foundations, Lesson 4. Okay, today we're going to be looking at the slope of a line. Okay, our goals are essential learnings. By the end of the lesson, determine if a line has a positive slope, negative slope, zero, or undefined slope. Find the slope of a line using a coordinate plane, and find the slope of the line using 2 points from the line. Okay, now, when we look at slope, it's something that we kind of understand in some ways just based on what we see. You know, a slope is a tipping in one direction or the other. Okay, I always think of slope in terms of the gas gauge on a car. Most gas gauges have empty on the left, full on the right. So if it's pointing to the full, that's positive. Okay, it's going uphill from left to right. Okay, that's also positive. You know, we look at a negative slope. You know, that's pointing to the empty on the gas gauge. You know, that gives us a negative situation. Zero slope is flat, like a table. And then we do have an undefined slope, which is actually a vertical line. Okay, and we'll see why that's undefined when we look at the formula. Okay, before you start doing your calculations, you should always look at the line and know what type of slope you're getting, what type of slope you're looking for overall. Okay, now, when we look at slope, there's a lot of ways to remember what slope is. Okay, it can be the vertical change from one point to another over the horizontal change. A lot of people call it rise over run. We've seen that a lot. And then we also have the mathematical symbol notation, change in y over change in x. Okay, all three of those are talking about the same thing. But what we want to do, it's one of our most important figures in all of geometry, is create a triangle. And the triangle shows you the distance that you're moving horizontally, a distance of 2. The distance you're moving vertically is a 3. And we're always trying to work from left to right and see what's happening. So from left to right, I've got a positive 2 for the change in x, a positive 3 for the change in y. So my slope, or we call it m, equals 3 over 2. Change in y over the change in x. Okay, so that's what we can do when we're looking at this scenario. If we have a graph, if we have the points on the graph, it's real easy to make that triangle from perfect point to perfect point. Okay, once again, we know we're going uphill here. So we've got a positive slope. We have a change in x of 3, a change in y of 2. Okay, so it's always rise over run. Okay, so our slope in this situation is positive, and it's a 2 over 3. Okay, now let's look at a negative slope. Okay, we have a negative slope in our line right here. Okay, going from point to point, drawing our triangle. Okay, now as we go from left to right, we're going down 1, but now we're still going to the right 4. Okay, so we have a positive distance being traveled in terms of x, but our y value is going down. So our slope, change in y, negative 1 over change in x, is a 4. We always want the negative in front of the equation. We don't want a negative in the denominator. So if you think about it in these terms, okay, that will help you with that process. Okay, one extra one I want to look at here. Okay, if we think about what's happening between these 2 points, there is no up-down change in y. It's 0. Okay, over our change in x, okay, we do have a change in x of 4, Okay, so our slope would be 0 over 4, or we would have a slope of 0. Okay, now, if we had the vertical line, okay, like we have here, we've got our vertical line, the change in y is 3, but the change in x is 0. Okay, we can't divide by 0, so that's why a vertical line has an undefined slope. Okay, now, formula-wise. Okay, the most common formula for slope is what we see here. y2 minus y1, x2 minus x1. But what we have to understand is it doesn't matter what point is where. The only thing that matters is that you're grouping the similar values. So we can have y2 minus y1, then we have to have x2 minus x1. They have to be paired top and bottom. Or we can have y1 minus y2. If we start with y1, we have to start the bottom. Okay, I just made the mistake I was going to tell you about right there. Okay, so we have to start with x1 and subtract x2 to find that distance between the 2 points. Okay, so if we're looking at our slope of what we see here in the graph, okay, we can set it up 2 ways, and I'm going to show both just so you can see how it works. We can go y2 minus y1 over x2 minus x1. Okay, we have to work through and simplify. 3 minus 1 is 2. We've got 1 minus a negative 2. 1 plus 2 is 3. Okay, it makes sense. Our slope is going uphill, so it's positive. So we get a slope of 2/3. Now, if you flip the 2 points around, let's look at the same equation, okay, but just in the different order. We can start with 1 for our y value and subtract 3. And then if we start with the 1, we have to start with the negative 2 and subtract 1. Now, this is going to look like it's different initially, but it's going to simplify to give us the same answer. 1 minus 3 is a negative 2. Negative 2 minus 1 is a negative 3. Notice that we have the 2 negatives that will work out and divide out to give us a positive slope. Okay, so you always have the 2 ways that you can set it up, and what I would suggest is try to work with your points to work with positive values versus negative values. It just makes your work a little bit easier. Okay, now a couple more here. Just working through finding the slope of the line in this situation. Okay, so our slope, or m, equals, and you can really go in either direction. Now when I'm looking at this, I see that if I do 11 minus 7, I get a positive value. So then for my denominator, I'm going to go negative 2, making sure I'm pairing the first values from the first point, and then I have to pair the second values from the second point. So 11 minus 7 is 4. 2 minus a negative 3 is a negative 5. And now remember, we don't want to have the negative in the denominator of the slope, so we want to put the negative out in front, or actually attach it to the numerator of the slope. Okay, so now, if we think about it, we've got these 2 points on the line. How can we find 3 more points on the line? Okay, what we could do is just going from the 3 and the 7. Okay, think about what a slope does. A slope helps us count. So from this point, I would have to go down 4 and right 5. Okay, now I could even flip this around. I could go up 4, but then I would have to go left 5. So we can use that slope as a counting tool to finish and find some extra points. So from, okay, and I have to be careful what I'm looking at. My y is down 4, so I go from 7 to 3. And my x, right 5, right is a positive movement, so then I would have 8/3. We could test and make sure that this is working properly by finding the slope of this line. We could do the same thing by working through that pattern and finding an extra value. Y's down 4, so 3 minus 4 is a -1. X is going up 5, so we go from 8 to 13. Okay, but we could also go in the other direction. We could do y's plus 4, that gets us to 11, and x's minus 5, 3 minus 5 is a -2. And if you notice, okay, that gives us one of our original points. Okay, so that's what we're working with and finding those individual values. Okay, now, if you have a missing piece, and this is one of our last parts here right now, if you have a missing piece like this and we're missing our y value, we have our slope that we're going to work with, y minus a -2, okay, putting the variable first to keep it positive, and then we have 4 having to pair up that first point and second point minus a -4 equals a slope of 1/2. Now, just like we looked at in the midpoint formula video, one thing we're always trying to do is have equal proportions, equal fractions, because that makes our life a little bit easier. We have y plus 2 over 4 minus a -4, which is 8. 4 plus 4 equals 1/2. And remember, this is what we're always looking for algebraically. We're looking for 2 equal fractions so we can work through the rest of this problem with a cross multiply. 8 times 1 equals 2 times y plus 2. 8 times 1 is 8. 2y plus 4. And then we go through the rest of our algebra to solve. Subtract 4 from both sides. 2y equals 4. We divide by 2. And we end up with y equals 2 for our solution. Okay, and then we could keep going, same pattern here. Okay, so this does conclude our lesson, working with slopes of lines. Thank you and have a good day.